Okay, so our session 7 is tides and tidal streams. So what we're going to run through is a little bit about tidal definitions, levels, and datums, tide tables, use of Admiralty method of determining tidal height, standard port awareness and corrections for a secondary port, use of tidal diamonds. So tides, the basic idea of tides. Okay, I hope I've picked up the right one. We are doing session 7, aren't we? It's our 7th week out here, just to confirm. Yeah. Okay, so the tides are the rise and fall of the sea caused by the combined effect of the gravitational forces exerted by the moon, the sun, and our planet spinning. So there's actually a whole bunch of forces that are involved. Okay. So the photograph, by the way, is the same place at high and low. It drops considerably there. Tide tables can be used at any given locale to find the predicted times or amplitude. That's the tidal range, how much it comes in and goes out. However, these are only predictions, guys. The actual tidal height and the effect of the tide, wind, atmospheric pressure, all that sort of thing can adjust them. So if it says it's going to come in 2 meters, it could well only come in 1.5 or come in 2.5, just depending on what the atmospheric pressure is. And we've all heard of tidal surge and things like hurricanes, where you've got extreme low pressures and the tide gets extra high. So these are just predictions. So always give yourself a bit of leeway on tides. Okay, so how do they work? We've always got the 2 major lunar bodies near us. And when I say near, relative, okay, enough to create a gravitational effect on us. So the first one is the lunar pull. It's obviously the moon, okay, and then we've got the pull of the sun, which is the solar pull. Now the 2 of them both have an effect on the planet, and the water on the planet obviously moves. It's liquid, it can move, and gravity is affected by it. So it's affected by the fact that, one, the Earth is spinning, and then you've got gravity pulling the water to one side, but the Earth then spins underneath that. So that's why your tide sort of just sits and then fills and fits and fills and things like that. When the Earth and the moon and the sun and the moon and the sun are in line, you've got both gravitational forces together. That'll give you a spring. Okay, they're called spring tides. Okay, so it doesn't matter if the moon is that side or that side. Okay, you've still got the effect of both of them being pulled together. Okay, and then when they're in opposite directions, you've got neap tides. So the effect of the sun is cancelling some of the effect of the moon. Does that make sense? So what we've got is, this is a beautifully drawn 90-degree picture. That's your ultimate. That means that if the moon is here, or here, or here, there, but not directly in line, it's not going to be quite as big a spring, but it still springs. And inversely, if the moon is coming a little bit here or a little bit there, it's still going to be neaps, but not necessarily as huge a neaps as a full directly opposite pull. Okay, there's a new lunar or a full moon about every 2 weeks. And that's about how often we see a neap in a spring tide. So it goes in and out, and the springs and the neaps change about every 2 weeks. Okay. Daily tides are therefore caused by the sun and the moon as the Earth literally goes round on its own axis. So we're moving and the water moves a little bit less because of the lunar and the solar gravitational pulls. So different tides are types, okay? The tide isn't the same as it is where you are, where we are. Like, for instance, the guys in States, they've got mixed tides. So if we look at the 3 different types, the red ones, that's called semi-diurnal tides. That's 2 equally high lows and highs each day, which is a good majority of the world, okay? Specifically around the Atlantic, okay? Then you've got locations which is a diurnal tide, not a semi-diurnal. That's the yellow sections. And they only have one high and low each day. Often around very, very island populated areas, Caribbean, or around here around Yucatan Peninsula, up here where there's a very, very big ice influence, the same, a big ice influence up here. Down here, you've got a big influence coming from the Southern Ocean. So those only have one high and low a day. And then you've got mixed tides, which is the blue section. And these guys have two uneven tides every day. Okay, and it's completely irregular. So you could have a very high, then a low, and you could have a high and a low quite close to each other, and then a high and a low quite far apart from each other time-wise. So they're quite mixed. Okay, and this is basically to do with currents, movement of water around the planet, where it can actually flow easily, where it's got very, very strong natural currents. So for instance, in the North Atlantic, you've got that Gulf Stream coming across here. That keeps a very constant flow, constant temperature, all that sort of thing. Same thing in the South Atlantic. You've got a very nice constant current coming here until it gets to about here. Then the current goes all over the place. So in areas where you've got constant currents, like coming down the African coast there, very constant currents going up the east coast, the west and east coast of Australia. Same thing, you've got very constant currents. Here you've got very disturbed currents. Here you've got a real mess because of all the islands. Same thing, a bit of a mess because of all the islands. Okay. So it's all to do with what the water does and how it can move around. Okay, so if we look at chart datum very quickly, okay, and we looked at this earlier, so it shouldn't be any news to you now. That's your dry section, okay. Rocky shore, that'll be a rock that's dry, but we've got the lowest astronomical tide, which is the one which shows us our water. Okay. So this rock will be exposed at the lowest astronomical tide. The lowest astronomical tide is as low as the sea will get with that tide recorded in that area. Okay. Up here is highest astronomical tide. That's as high as it'll ever get. Okay. Where they don't have tides, they just use mean sea level, the average sea level. Okay, so Baltic. So if we look at that in bigger definition, highest astronomical tide, that's the highest spring tide you'll ever get. It's absolutely recorded the highest you ever get. Then you got your mean high water springs. That's your average high water tide. So you take all the high water tides across the year, that's your average one. That's your highest one, that's your average one. Okay? You get the same thing down here, mean low water springs. So that's obviously high water neaps, mean low water neaps, mean low water springs right down the bottom. That's your average spring lows. Okay? And then you've got chart datum, this red line. That's your lowest tide you'll ever get. That is what our charts are based on. So if you see a depth on a chart, it's what's below chart datum. So if you want to actually find out your, or above the drying height. So for instance, tide where this boat is now, that drying height is actually underwater. Okay, so depth is your charted depth below chart datum plus your height of tide. Okay, that'll give you your depth. Or,
and Wavy, are all charts based on LAT?
yes, unless they're, as I said in this one, if I go shoot back quickly, unless they're non-tidal waters, then they mean sea level.
Okay.
Okay, so the Baltic, the Med, things like that, where the tide's negligible, it's recorded as mean sea level. Otherwise, it's definitely highest astronomical tide, lowest astronomical tide, or chart datum. Your depth is below that. So depth, charted depth, what's below your LAT, your chart datum, plus your height of tide, or your height of tide less your drying height. Because remember, your drying height is above chart datum. So it's one or the other. So just for interest's sake, for instance, when we're trying to work out the underside of a bridge, all charts have the clearance under a bridge from highest astronomical tide. Because obviously that's as high as it's ever going to be for you to get under that bridge. Inversely, this is the lowest tide closest to the bottom. It's the lowest it's ever going to be. Okay, so there's your charted depth literally in height of tide. So there's charted depth plus height of tide giving you depth below that boat. The depth here is literally just that. So it's your height of tide less your drying height. So we know at chart datum there is this much drying height, and we know at the moment we got this much tide, so we subtract one from the other and it gives us that little spot there. Okay, so why do we need to know our depth? Well, I think there are lots of reasons. But if we look at it quickly and I do a little exercise, and there's a good example of why we need to know our depth. Your depth gauge reads 3.2 meters at low tide. So it's now low tide, and you've got 3.2 meters below you. If you want 4 times the depth of chain, so whatever your depth is, you need 4 times chain. How much do you need to put out if you plan to be there at high tide? And your tide table says that your low tide is currently 1.2 meters and it's going to go up to 4 meters. So the first question is, what is our charted depth? We know it's low tide, so we know we've got a tide of 1.2 meters. So what's our charted depth? It's going to be the 3.2 on your gauge less your tide giving you your charted depth, your chart datum. So that gives us how much chart datum we've got.
Can you say that again, Wavy?
So your depth gauge reads 3.2. That's what you know. That's the water underneath you till it hits the bottom. That's what
Right.
the depth gauge is telling you. We know we're at low tide. Okay. And we know at low tide, there is a 1.2 meters height of tide. So if we take our 3.2 and we remove our tide, we get our chart datum.
Okay, thanks. Sorry, I'm the slow kid.
Okay. Our maximum tide is going to be 4 meters. We know that from the tide table. We add that to our chart datum, we're going to get a maximum depth at high water at 6 meters. So therefore we need 24 meters of chain. So if we look at that, expand it a bit, there's our 2 meters chart datum. There's our maximum height, was 4 meters. That gives us our 6 meters total. But when we started, it was 3.2 meters, 1.2 meter of height, 2 meters of chart datum. So let's try another one. You want to anchor overnight when the tide will go in and out. Okay? Your draft is 3.5 meters. So you need a minimum of 4 meters of depth. Okay? Your high water is at 1843 at 6.1 meters. Your low water is at 0040, so midnight, just gone midnight, and it's only 1 meter deep. How deep must the water be when anchoring? So what we're looking at is saying, how much chart datum do I need under my 1 meter of tide? Okay, so we need a 4 meter minimum. So 1 meter of low water plus our 3 meters charted depth. That will give us 4 meters minimum at our low water time in midnight, midnight 40. Currently we're at high water and it's 6.1 meters. So our tidal range is 5.1 between the two. That means the water is going to drop 5.1 meters down. Okay? So we need to take our 5.1 meters of drop plus our 3 meters of charted depth plus our 1 meter of tide, giving us 9.1 meters of depth total. Therefore, when the tide goes out, it'll drop by 5.1 meters, leaving with 1 meter of tide and 3 meters of charted depth, giving us our 4 meters total. So there we go. We are currently high water. It's 6.1 above chart datum. Okay. At low tide, it's only going to be 1 meter above chart datum. So it's going to go up and down, okay, by 5.1. Okay. We need 4 meters minimum, including what's below chart datum. So when it comes down to 1 meter, we're going to need 3 meters of water underneath our boat to give us our 4 meters minimum. So we're going to need 9.1 at the top. So when it goes down 5.1, we're going to be sitting at low water with 1 meter plus 3 meters of chart datum. That'll keep us floating 4 meters above the bottom. So you could well be anchoring in an area that's much, much, much shallower than what you assume because your boat's 3 meters deep. Okay, so that's one of the reasons we need to know our tides quite well. So we don't hit the bottom all the time, or we can get over things. Can I get in and out of a port if there is enough water, if it's not a 24-hour access port? The next reason we need to know our tides is tidal stream. Okay, this is a Alamy photograph, but I love it. So give them credit where credit's due, but fast flowing tides and quicksands. I think it says it all with the amount of water flow. Okay, so tidal streams is the speed and angle at which the tide comes in and out. So tidal heights, what we've just been doing now, is how much it goes up and down in meters of depth. This is how quickly and at what angle it comes in at. So two completely different things, caused by the same event, the sun and the moon and their gravitational pull and the spin of the earth, but the one is all about how deep is the water. This is about how much it's moving and at what angle. Okay, for those who know the 7 bore of the incoming tide, I mean, it happens in the UK every couple of months or every year. I'm not sure how often it happens. The tide is so strong up the Severn River, it creates this permanent wave, and the guys surf it. And they get very upset when they fall out because they can't get back there. It goes too fast. Okay, so we've now got moving water. Oops, hang on. Do I need to just pop out and pop back in again? Hang on. The block. No, I'm gonna have to stop sharing for 1 second and share again, otherwise that orange block pops up. Back again?
Yes.
Okay, so we know they've got tide moving. We've got the water moving either one way or the other as it comes in and goes out. What's the effect of wind on that? If you've got water, tide moving in, and wind going the other way, it creates incredibly aggressive seas, really, really aggressive seas. Okay, far more so than you'd think. Even in light breezes, you still get very aggressive seas. When you've got tide with wind, the two moving together, even in quite aggressive winds, the seas are very calm. So you really want to be avoiding wind against tide and targeting wind with tide. Okay. Then there's other effects like overfalls. Okay, so if you look at this picture, in front here it's reasonably calm. Then you've got this section of, as you can see, very, very lumpy seas. You can see this yacht beating his way through quite big swells. And then just beyond it, not far beyond it, it goes nice and calm again. That's the effect of tide coming around headlands or going over shallows underwater. Creates, again, quite aggressive seas. This one is off the Isle of Wight, the Needles off the Isle of Wight. So I think most of you sailed around that. But that's quite an aggressive overfalls there. And it can get very wet. Some of you might have seen as we were sailing in there, to the great amusement of the entire crew on Bermuda, a wave broke over the back of the boat and just landed on me while I was helming through. So to everybody's amusement, I was absolutely soaked. So where do we get our tidal information from? And it's the tidal streams and the tidal heights. Your source information is tide tables. Okay. They give you highs and lows each time. They often give you lunar phases, because obviously it affects the tide quite heavily. Okay. So, and then they'll give you sunsets and sunrise and moonsets and moonrises, other useful information that appears on these things. They are very much dated. March 2020, and then days of the month. Okay. Most of them are published by hydrographic officers. Government officers publish them. But they are recorded in certain ports only. So that's literally, that's a tidal height measure. Somebody comes and records it every day, high water, low water, high water, low water, and they get a table of how much the tide's going in and out, and then they know exactly what's going on. So that's a standard port, and somebody records it all. But what about all the ports that don't record it? They're called secondary ports. You don't usually get tide tables for a secondary port. Okay. So you need to then work off a standard port. And there's a special way of doing it, but we won't get into that now. So standard ports. Here's Portsmouth, January last year. Nice printed. There's the day of the month. There's the morning, afternoon, high water, low water. There we go. And it gives you a time and a height, a time and a height. And then the same for the low waters. Time, height, and some of them will do it sort of high, low. Some of them will do it as this one is, all the high waters, then all the low waters. It just depends on how they publish it. Phases of the moon, still there, just displayed in a different way. So it's the same information. That gives us our information. So here's high water, Portsmouth Harbour last January. And if we wanted to leave and get over sort of a shallow area of Portsmouth on the 10th, we would say, oh, well, my first high water is at 22 minutes past midnight. Well, I'm not going to ignore that one. And the next high water is around 1 o'clock. Great, that's perfect time. And you've got 4.5 meters of tide. Lovely, that's lots of water, even for a drying height. Okay. Remember to add your chart datum.
Hey, Wavy?
Expecting the water to be 4.5 meters deep on that day. That means at chart datum, that means that literally your chart datum needs to be 0 on that day. Otherwise it will be deeper because it'll be the chart datum water, or shallower because it's a drying height. So if we look at Portsmouth, that 4.5 meters, this whole green section here, it's very flat muds. With 4.5 meters of water on it, you can comfortably sail over that, even on the clipper boats. Okay. Yet, if we go back to the next low tide, 1.5 meters, this whole area won't be dry. There'll still be a little bit of drying height, plus that 1.5 meter of tide. The only time this area will be completely dry is at the lowest astronomical tide. Otherwise, we might well see water sort of flooding the edges, making these channels look bigger, things like that, because there is 1.5 meter of tide on top of this chart datum. So if you get out there and you go, God, this place doesn't look anything like what the chart does, it could well be because you're nowhere near lowest astronomical tide, which means there's still tide filling in the green spots. You know, so that's one of the reasons everything gets buoyed and marked off very carefully. So that's Port Solent, the top of Portsmouth Harbour, and it's got a very nicely buoyed channel all the way down, gets you into the white, which is the nice deep water. Okay. The white areas, I'm just saying here, you can always keep deep water there. On most charts, it probably is white, but don't guarantee it. Remember, charts do use different colors. So, how do we know how the tide comes in and goes out? Okay. This is the speed and shape that the tide will come in Portsmouth Harbour. So it actually takes, between low water and high water, it actually takes 7 hours to come in and 5 hours to go out. And as it comes in from low water, it'll have a little bit of a shoot up, and then it slows down a bit, then it shoots up again, and then it slows down, it stays gently at high and starts ebbing very slowly, and then it shoots down very, very quickly. So the first thing this curve tells us is you're going to have more incoming tide per day than outgoing, because it's 7 hours and 7 hours, not 6 and 6. Still the same 12-hour gap, but more incoming. The second thing this will tell me immediately is that if the same amount of water coming in 7 hours has to go out in 5 hours, it's going to be flowing a lot quicker, isn't it? Because the same amount of water that went in has to come out. So the next thing this thing tells me, the red line, top right here, is your springs. That's your mean springs. It's your average springs. That's what the red line shows me. The dotted blue one, shows me what the tide does in neaps. So in neaps, it's far calmer. It doesn't have this whole jump and doesn't have that little jump there either. So it's much more smooth curve in neaps. So this is how they record all these tides coming in and out, Okay. So how do we use this tidal curve? There's all these numbers on the left and all these bits and pieces going on. Okay. So question for us, just saying, how deep will the tide be at 1540? Okay. There's our tide table. We collect our tide table information and we subtract our high water from our low water. That gives us our range, 3.9. We have a look at our little box here in the top right and we say, well, that's springs. 3.9 meter range is springs. So we'll definitely be using the red curve. We wouldn't use the dotted line curve. Okay, so there we got that information. If it's between them, by the way, guys, there is a little chart which we won't go through this evening because we could be doing this. When we do this in the classroom, it's a 3-day exercise to get all the bits and pieces done. But if it's between them, we have a computation of rates table which we use. So there is a way of doing it. Okay, so what do? We took our low water to height at 1.1, and we took our high water at 5. We just drew a line between them. Okay, high water at the top there, low water at the bottom for that day, and that's given information for us. That comes straight out of the tide tables. 5 meters at the top, 1.1 at the bottom. That comes straight out of the tide tables, and we just draw a line between them. And you see it actually says high water heights in meters, low water heights in meters. Okay. Then we just take our high water time, smack in the middle there. It was 12:03, wasn't it? Given to us in the tide tables. We go in an hour either side. So we know that the low water will be around 5 o'clock. The next low will be around 5 o'clock. Equal tides. Might be out a couple of minutes either way, but that's not really relevant to us because we're also taking into account tides are predictions in heights, not exact figures. Okay. So then we go along from high water. We wanted 13:45, and we go along and we go along and we go along until we get to 13:45. Because high water was at 12:03, 15:20, that's an hour later, and that's another 45 minutes later. And we just draw a line straight up to the tidal curve. Okay, so that's where that comes from. Okay, we then join the top. We just draw across parallel like that, where our tidal curve meets our time. So the vertical blue one here is our time. The horizontal red one is where it meets it. Okay? So it's literally on the red line there because of the springs. Where our original depth line meets our height of tide at that time is our height of water at that time. So if we look at our height of tide at 12:03, goes all the way up till it hits the curve, comes across from the curve until it hits the high water. Conversely, the same thing at low water, come up to the curve, bang, come across, there's your low water. Okay. So that's how we get a daily time tide. So that gives us 4.6 meters. Okay. Remember to add your chart datum or take away your drying height. Okay. But we can also work it the other way. We can say, okay, we want to work out when we can go sailing for that day, and we need a minimum of 2 meters of tide to sail safely. So we've got exactly the same thing. There's our low water, there's our high water. We know what the tide is for the day. Okay. We take our line from our 2 meter depth, and it meets there. So we come across to our curve. From the curve, we come down there and come down here, which means between that line and that line, we're literally going to have more than 2 meters of tide. So that the two work in reference to each other. This is our depths, this side. This is our time, this side, and the curve between them. So wherever the time comes up to the curve and goes across to the depth, that's depth. Wherever we want depth coming across to the curve, that's time. So they work, but they're all reliant on this curve. And curves can vary in shape enormously. They can be enormously different. Okay, so we can go from about 640 to about 1610. and we will know we have got 2 meters of tide, not depth, tide. Okay. When you're working off time, give yourself a little bit of leeway for the time. So don't leave at 1640 on the dot and hope it's going to be all the time. Remember we did the depth calculation for anchoring and we added half a meter to the tide just to be safe? You'd give yourself half an hour either side just to be safe. Secondary ports, we've got to use one of these tables to convert it to a standard port. So this is for Butler's Hard and Stansell Point, and we use that same tidal curve from Portsmouth, and we'd have to reference it back. Okay, but I'm not going to go into secondary ports. That's again another huge thing on its own. Can I just check? Did you guys manage to get the tidal curve? You managed to print one off or not? I think it was on the group. So let's try one here. 1203, we had 4 meters of tide. 1750, we had 1.2. What is our depth at 8:10 in the morning? I hope I've got that right. It looks a bit. So, high water in meters, low water in meters, high water in time. Okay, so if we have a look at it, it should look something similar to that. It should be about 2.1. So your high water, 4 meters, low water, 1.2. Okay. Your high water time, 1203. So we come back to our looking for time of 8 o'clock. Come up until we hit tidal curve, come across, come down to about 2.1, 2.2. So I see most of the answers were pretty much there. Okay, a little bit about tidal diamonds. They're on the charts, they look like that. Okay, they'll only appear on tidal charts where there is tidal stream. So you won't see them on any charts unless the tidal stream is recorded. Okay, and that relates to a whole bunch of information at the top of a chart. Each tidal diamond has its own little page of information, little line of information. Okay, and these reference a specific standard port. Okay, so for instance, this picture here references Victoria. Okay. It's tidal diamond A, and it gives you the Latin long of where it is. Okay. So when I say references this standard port, okay, that means it's referenced to their tide tables. So if you're looking for a high water time, a low water time, and a high water height and a low water height, it'll be referencing there. Okay. High water in the middle. So it's saying at high water, at this tidal diamond, the tidal stream will be 171 degrees, so almost south, at 1.1 knots at spring tide, or 0.5 knots at neap tides. So that's the angle of flow, and that's the speed of flow at spring and neaps, at that geographical position. Okay. So therefore, the tide comes and goes every 6 hours. That will be the speeds it does and the directions it does for the next 6 hours. Okay. That position. And the same will be on the tide chart. And if you remember when we did those course to steer exercises and we had to look at course to steer, we get this information to be able to do that, our course to steer information. Okay, so what will the tide be 4 hours after high water neaps in tidal diamond A? It would be 4 hours after, so 113 degrees, and it's neaps, so it'd be 1.2. Tidal streams give you exactly the same information. So tidal stream atlas is just a visual representation of these numbers. So literally, that's just telling it that it's flowing in a northwesterly direction at those speeds. Okay. It's usually based on a high water plus or minus a number of tidal hours. It's exactly the same as the one page before. So there's a direction of flow, same as the other one does. And your speeds are the numbers behind. What a stream atlas does, it visually represents how fast the stream is. So you can glance at it and go, okay, the stream in here is far less than the stream in the middle, rather than having to look at each tidal diamond and try and work it out. So it's just a much quicker way of referencing it. So for instance, this stream atlas will have a page for 6 hours before, and then another page for 5 hours before, and then another page for 4 hours before, and so on until it gets to a page for high water, and then it'll go all the way up to the other side 6 hours before, 6 hours after. Okay, so is the information in the tidal stream atlas the same as tidal diamonds? The answer is very, very much yes. If you look at a point on the tidal stream atlas where a tidal diamond is, those numbers will be identical. The angle of flow and the speeds at neaps and springs. Okay. When creating a course to steer, can I use different tidal diamonds? Again, the answer is a resounding yes. And remember, tidal information is only given to you in an hour-to-hour basis. So if we look at that tidal diamond, it was 1 hour before, sorry, 6 hours before, 5 hours before, and all the way to high water, and then 1, 2 to 6 hours after. So every hour it changes. So you need to do it every hour. So therefore you can use multiple diamonds and multiple hours. When creating a course to steer, can I use diamonds and tidal streams? Okay, again, very much so. You can use both of them, but the streams give you a little bit more detail. So you can be slightly more accurate with the streams. So that gives you a brief introduction into tides, from where they come from, and the two aspects that we really, really use them for. One, the depth. So how deep is it going to be at this time? Or between what times have we got that depth? How deep is it going to need to be for me to anchor? Okay, so that's the tidal curve. The other one is, how much influence am I going to have when I'm sailing in this direction from the tidal stream, and how much of the, and what direction is it going to go? So in other words, when I'm sailing along here, as the tide comes in, is tide going to be against me or with me? Is it going to be strong or is it going to be weak? Because that can obviously make a huge difference to where you end up. So if you're sailing along, okay, and you've got 3 or 4 knots of tide with you, and you're sailing along at 6 knots, you're suddenly doing 9 knots, maybe 10. However, if you're sailing along and you've got 3 to 4 knots against you and you're doing 6, you're actually only traveling over the ground at about 3. So it's quite important to actually know what your tide's doing. We do loads and loads of examples, both at sea and in the classroom. It's covered in both practical and written exams, so there's lots of questions about it. And you have to get this right for passage plans. Otherwise, you can't plan a passage effectively, even if it's just going to France to go and buy some wine. If you don't get it right, you're going to literally be sitting there punching tide. In fact, France is a bad example. Let's go to Alderney for wine. It's duty free. Okay, so we've got all the contact details. Next week, we'll talk about aids to visual navigation. So lighthouses and beacons and light characteristics and where they come from and we use them. And then we'll touch on a bit of meteorology. So the sources of meteorological information, the common terms we use for shipping forecasts, both at scale, things like that, and then a basic knowledge of highs, lows, and fronts. So we'll just touch on those next week. Again, it's a huge topic, enormous topic, meteorology, and I'm going to try and top on it in literally half an hour. So, but we'll do our best. Okay, here we go, guys. How are we doing? Let's get everybody unzoomed. How was that?
Oops. Good, that Wavy.
It ran on a little bit there. It's 8 o'clock already.
No, that was really interesting. It was great, really interesting.
You joke. We literally, and I mentioned just going across to France, when we were living in Southampton, well, not in Southampton, Hamble, we just literally do a tidal curve. Okay, let's shoot across to, say, Weestrum or Cherbourg or whatever, and we literally just very quickly, okay, scribble it out, do a tidal curve. Yep, I can get in there. Great. Whip out the tidal stream atlas. Which way is the tide going? Is it beneficial? What can we do? Okay, we're going to go this way or that way, and we'd sail across to France. So both of those things we've just done now, we just automatically do before going over to France. And wife and I we used to literally sail across to France just for a dinner on Friday evening. And we do those calculations just to go to dinner. Where you really need to get your tide right is if you decide to have lunch up the Beaulieu River. Because you get that one wrong, you stay up the Beaulieu River until the next high water. It literally dries on you. But again, we just do them very easily. Little tidal curve. Beaulieu River happens to work off the Southampton tidal curve. It doesn't matter. Same idea. Quickly, okay, we can enter by this time, but we have to be out by that time.
Wavy, is it more normal that you start off with the high water minus and plus, or can you actually do it from low water?
That depends on how the curve is written.
Okay.
Okay, because you do get low water curves, but the curve is actually drawn upside down.
Mm-hmm.
So instead of the curve looking like a sort of an
mountain,
mountain, yeah, it looks like a U. You know?
Okay.
You got me. So then you have your low water in the middle.
Okay, so if it's a mountain, you would always do high water plus and minus.
If it's a sort of a valley, you would then use the low water.
Okay.
Hey, Wavy, where do you get the source information for those, for specific areas?
Oh, you can literally, 90% of tidal information is freely online, freely available. So you can literally, if you want the Southampton tidal curve, you can just type it in and Google it and it'll pop up. If you want the Portsmouth one, you can just type it in and it'll pop up. So assuming there is a tidal curve for a place, they're readily available. Otherwise, you can use books like the nautical almanacs and things like that. Yeah, there you go. Someone's holding one up now. The Reed's Nautical Almanac. There's
Bit of
tidal
light
curves on each
reading.
and every one of those ports.
Not much else to do this time of year, is there?
What, work out tides and secondary ports. Yeah, so that book that Tom was holding up, if you look at the start of each one of the little areas, it has a tidal curve drawn in there that you can use. The only thing that annoys me about the Nautical Almanac, especially the Reed's one, is they seem to think that nobody actually needs glasses. The tidal curve is tiny. And I'm afraid my eyes aren't that good anymore. I've got to photocopy it bigger to use it. Does that answer your question then, Arnold?
Yeah, it's it. Perfect.
Tom's showing me a really. How'd you do with a pencil through that one, mate? Yeah. Okay, guys, any other questions?
That was great. Thanks, Wavy.
I hope it wasn't too numbers for some people, that some people don't like the tidal stuff because it becomes very numbered.
So you don't have to plot the chart yourself?
No, not at all.
Right,
You just
okay.
stick it on the tidal curve and then you know. And then you just
Right.
add whatever tide you've got to your chart Datum, or take it away from your,
Yeah.
or you just look at the tidal curve.
Yeah. I mean, you don't. Ah, okay.
I'm trying to show you a
Alright.
tiny
Yeah.
tidal curve.
Okay. Yeah. Yeah. Got it. Okay.
So, I mean, the information is readily available.
Right.
And if you can, try and get the most up-to-date tidal curve, because humans are really good at filling in pieces of land or digging up pieces of land and building new marinas, and that tends to change tide movement. But it's either got to flood a new area, or the area where it used to flood is now full of land. So reclaiming land or exposing land for new marinas affects tidal flow. Not that I can say a thing, considering half of Cape Town is reclaimed land.
Right.
Okay, guys.
Okay.
Thank you very much.
Thanks a
Thank
lot.
you, Wavy. Thank you.
Thanks.
Have a good weekend, everybody.
Okay, bye,
Yeah.
everybody.
You too.
Next week.
Bye.
Bye.
Bye.